Hey everybody, this is Wednesday, October 9th, and it is very early in the morning because I just figured out that I am not coming in today. I hope that you guys have a wonderful day, and I'm sure you were due to the lack of my presence there. But it's all good. If you were the rare Carlson fan, I think I'll be back tomorrow. I just need a sec to rest and get feeling better, and it'll be a good time to grade some stuff anyway, so... I decided instead of moving on today that it would be a good idea for us to just practice some skills that you're going to need a whole bunch in our linear functions unit. So I left you a little bit of practice in these notes also. Hopefully 15 minutes, which is as long as I'm allowed to record, will be enough for us to get through these. So let's check them out. We're going to need to focus pretty heavily on rate of change and slope as we move forward in our linear function stuff. So we've got to know what we're talking about. When I say rate of change and slope, I'm going to use these pretty interchangeably. Rate of change means a ratio that compares the growth of x and y. Is one getting bigger faster than the other? Are they getting bigger, relatively the same as one another? Stuff like that. When we talk about this on a graph, we tend to call this the slope. The slope of our line. Slope is always written as, here's the word ratio again. It's a ratio of the vertical change, which we call the rise, versus the horizontal change, which is the run on our graph. Alright, so on my slope, when I look at my line, my rise is going to be this vertical piece right here. See how my sideways writing is doing today. So great. Versus my run, which is side to side. What's nice about our linear functions is that this is going to remain constant throughout our entire line. So it does not matter which 2 points you look at. You can choose any two that are convenient for you. And this is written as a fraction in simplest form. In simplest form. So if we can reduce our fractions, we would like to. For instance, if you have a 14 over 2 for your slope, it would be nice if we could turn this into, we'll divide by 2 on top and on bottom, 7 over 1. If you make $14 every 2 hours, you're really making $7 every 1 hour. This is not that big of a deal for 14 over 2 because our brains can think about this pretty easily. But if, for instance, I told you that I made $98 every 14 hours, you have a harder time figuring out if that's a decent amount of money or not. So you can reduce this one also to 7 over 1. And then when you have $7 every 1 hour, you have a better idea of figuring out, oh man, I'm not getting paid very much money. I should probably quit this job. So anyway, we're going to be doing some reducing here. Our variable for slope is going to be m. That's what the world uses. It makes so much sense that m is going to stand for slope because... Next slide. Cool. Types of slope. They come in many different flavors, and it's all about which direction your line's pointing. Does your line point this direction? Does your line point this direction? Maybe your line is perfectly horizontal like this. Perfectly horizontal, I said, as I drew a really terribly horizontal line. Or maybe you have a vertical piece. These 4 flavors refer to what your y value does as you go left to right. So as we go left to right, we are writing this thing upward, right? If I write the word slope on top of here, I'm going up. So this is positive. Happy things are happening to us. We're making money. Oh no. On this graph right here, left to right, I'm going downward. So we're losing money. This is a negative slope. If you're just going side to side, this is like us walking on flat ground right here. I would never call something like that sloped. So this tends to have a 0 or a 0 slope. Alright, this is like the numerical 0 right here, not just a big O. And then this vertical piece is what is undefined. It's undefined because I can't actually tell you how fast this thing's rising because there's no side to side to compare it to. Maybe this thing's going up and down, but it's just going up and down very, very slowly. And you know what? Never mind. I don't like my example. If it's going up and down, it's undefined. We can't find that slope. Finding your slope on a graph is really nice because we're really just counting. I'm counting how much my y value changes. That's what this little triangle means. Change in y over change in x. How much does our rise change? And then how much does our run change? And we just smush them together in this really convenient little fraction here. When you're doing this on a graph, you can pick any 2 points you like. So you can make it as easy or difficult for yourself as you want to. But we always want to pick some that are on nice even grid lines here. You can see how that's like right at the corner of those squares. And then I can just count my way up and then over to find out how far I've gone. Notice I went up until I was even with this point right here, and then I moved my way over. And also notice that I started at my left point and went to my right point. That's a good habit to get into. Now we can just count. How far up did I go? 1, 2, 3, 4, 5, 6, 7. I count 7 boxes there. And then 1, 2, 3, 4. 4 boxes to the right. So my slope here, m, equals 7 over 4. Box that thing. It's finished and it's beautiful. We're going to do the same thing in number 2. Make sure that you start at the left point and go to the right point. And then just count your way up and down first. So I'm going to drop until we're even, and then move over until we touch. And then we count down 1, 2, 3. Because I'm moving downward, I'm going to make this -3. And then we count over 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces. So our slope here, m, equals -3 over 9. But wait, this can be simplified. 3 goes into both of them. So if 3 goes into the top, -1 times, and 3 goes into the bottom 3 times, our slope here is actually -1/3. And you can see that if we go down 1, right 3, it still keeps us on our graph. We could have chosen that point also. Very quickly, these graphs down at the bottom. Oh, look, it's horizontal. A quick check of my reference up above says horizontal means 0. M equals 0. And then this vertical line right here, I can't actually do this because I would say, okay, rise was 1, 2, 3, 4, 5 between these points. Rise is 5, but run is none. Well, 5 divided by 0 is not something we can do in math, so that's why this one is undefined. I hope you guys are having as much fun as I am. And it gets even better from here because we get to go straight into our slope formula. When you're given points like coordinate pairs like this, we can build a formula as m equals subtract my y values, y2 minus y1, divided by subtract our x values, x2 minus x1. This formula is really important, but I tend to, instead of referring back to it, just kind of really get into a rhythm with how to use these guys. Once you develop a rhythm yourself, you're going to find that it's pretty easy as well. So I'm going to make a note to myself on this page that m is equal to subtract my y's over subtract my x's. And now I'll show you guys the pattern that I use every single time. I know that when building this, I'm going to have a fraction, and I know that my y's are going to be on top. So what I do is I say, okay, I've got xy, xy. Well, let's identify our y's first. This is a y here and a y here, so I'm going to subtract these. And I always subtract them backwards. So I go 3 minus 1. That'll go on top of my fraction. And then with my x's, I do the same thing. Identify my x, and then we subtract backwards 4 minus 1. So in reverse order there, and then we simplify. 3 minus 1 leaves us 2. 4 minus 1 leaves us 3. So our slope here is equal to 2/3. Hopefully you didn't think that that was too bad. We're going to go through the same process again. Here are my y's, underline them. Signs can get a little bit tricky, so just make sure that you're talking your way through it. -5 minus 5. This is going to be over my x values, which are here and here. So remember, I subtract backwards. I do -8 minus -4. Did you hear both minuses in there? Minus -4. So we've got minus a negative here. I think we talked pretty extensively last week about how subtracting a negative is really just a positive, so I'm going to make that a plus sign. And now we'll put them together. -5 minus another 5 is going to be very negative. That's -10. divided by negative 8 plus 4. A negative 8 and a positive 4, the negative wins, and it wins by 4. Negative 10 over negative 4. We need to clean this up. First things first. Negative here, those guys can cancel each other out. Now, 10 over 4 can reduce. 2 goes into both of them. It goes into the top 5 times, and the bottom 2 times. So 5 halves. Let me write it clean one last time over here. M is equal to 5 halves. Neato burrito, as James Anderson next door would say. I don't like him. Okay, here we go. Number 5. We've got 9 and 9 are my y's, so I subtract backwards. 9 minus 9. Over, in red, we have 3 minus 5. So let's simplify it. This is 0 on top and negative 2 on the bottom. 0 divided by anything will give us a slope of 0. In number 7, 3 minus 9 going backwards goes on top. And 2 minus negative 1 goes on the bottom. 2 minus negative 1. My minus negative is basically a plus sign, so I'll take care of that. And now we subtract 3 minus 9 for negative 6, and 2 plus 1 for 3. I can reduce this thing. This is 3 goes into both of them. 3 goes in to negative 6 negative 2 times, and 3 goes into the bottom 1 time. And this is probably one of those situations where, since it's divided by 1, I wouldn't even bother with the fraction. I would just write m equals negative 2. You can always turn negative 2 over 1 into negative 2, or negative 2 into negative 2 over 1. These things are no problem. It's whatever happens to be useful for you. For writing an equation, we probably just want the number. If we're on our graph and we're trying to plot the points, we probably want the fraction because it tells us rise and run. The last problem, 5 minus 6, watch your order here, goes over 6 minus 5. So here we have negative 1 on top and positive 1 on the bottom. Just like up above, anything over 1 is not really worth writing as a fraction, so I would probably call the slope here negative 1. Okay, I want you guys to take a second, try out the evens from the right side. Try those out, and I will make an answer key on the next page so you can check and see if your answers to those ones are correct. Go ahead and pause me now, and I'll have the answers to those on the other side in just a moment. Pause. Pause, pause, pause. Seriously, do it. Pause right now. Okay, cool. I'm going to the next slide. Okay, here's my very roughly assembled answer key for answers 2, 4, 6, 8, and 10. I want to make sure that we feel okay about the difference between undefined and 0. Undefined happens when you have a fraction like maybe 3 over 0 when you have division that just can't be done. 0 happens when you have 0 over any other number, like maybe we had 0 over 5. And I can still divide this, it's just that 5 goes into 0 times. Alright, check your reducing on these, check your signs on these, okay? But if you can handle that, then I think that you're in pretty good shape. The assignment I left for you guys is right here, it's one-sided. You will probably need a piece of scratch paper to work on. So if you need to show your work on another piece of paper, go for it. There are 20 example problems. It's pretty hefty, but you probably have enough time to do one every 2 minutes and still wrap this up before you leave class today. This down here is to make sure you get into the Christmas spirit. I think that's really important on October 9th, that we're all thinking about December holidays. Good. The coloring is totally optional. If you don't want to match them up, that's fine. That's cool. Be nice to the sub, and I will see you guys hopefully tomorrow. Catch you later.